All right, here's a series of videos I want to do on designing a printed circuit board using Circuitmaker. Circuitmaker is a free software from Altium. And so this series of videos is just going to be on like the real basics of how to make a project. It's going to be like kind of quick and dirty. And then we have a significantly larger number of videos that kind of go a bit more detail on how to do things neater, nicer, better, to have a better design to make sure that it can be manufactured. So we're just going to go ahead and dive right in. If you don't have Circuitmaker, so what we do is go onto this thing called the internet, go to circuitmaker.com. You'll have to set up an account like normal, and you go to download, and then you download and then follow the steps, and it loads the software onto your computer. Now, Circuitmaker is a cloud-based software package. So it does save projects locally on your drive, but it's not, you have to kind of dig for it. But most of it, so all your projects are going to be saved on the web. So if we're going to start a new project, we can, like if we're under home, we can just go ahead and click add new projects, or you can go to your projects and continue on with a project you were working on. But here we're just going to go ahead and click add new project. So the project is the repository of all the folders and files you have for your project. So we're going to call it Boost, and we're going to save it in public. So you can have up to 2 projects in the sandbox. So sandbox is kind of like your private. You don't want anybody to see the design, but you can only have 2 in there at a time. Anytime you want to have a third, you either delete one of them or you move it into the public. So we're just going to leave that in public. You can put a description up there if you want, but go ahead and click save. And so this will start up a new project, and then we'll start with one of 2. You can also go in and edit. You can add images, descriptions. You can go back and change the from sandbox to public, but again, it won't let me because it says, oh, I'm at my max. So right now we're just going to keep it in public. And all right, so we're going to go ahead and click save. And we're going to open the design since we're not going to add any comments at this point. This would be where you can set up if you want to have a team, if you have more than one person working on it. We'll do that in another video. So there's 2 basic files that we're going to work with. So it's going to be a schematic and a PCB. So a schematic is just the symbolic, like it's the electrical flow and the logical how things are connected, whereas the PCB is going to be the physical connections. It's going to be all the traces on the circuit board. So I just click that, and we'll just give it a name. We'll call it Boost because we're making a boost converter, because that's what everybody does. And we're just going to go ahead and also start up a PCB. We're going to call that Boost as well. All right, so the schematic is basically this single sheet. This is where we're going to set up all of our symbolic representations of an electrical component. All right, so we're going to select this first LED, just as an example. You can see it has this the symbol of an LED, as well as it has the physical footprint. And we're going to just go ahead and click. So you can import this one of 2 ways. You can either just click and drag, so left click and hold it and drag. We're going to click place. We're going to click place, because it has an advantage. If you click and drag, as soon as you release it, it just places it. But we want to do a couple things. So we can just press tab before placing it, and we can check out the 3D model. So press and hold shift, press and hold the right mouse button, and you can maneuver it around. So it's got a decent footprint. One of the things that's nice is that it has this little dot on the silkscreen layer that indicates which is the, well, most likely which indicates which is the cathode. But I actually kind of don't prefer that. Instead, we're going to click this LED. So down here, it has the schematic symbol, as well as it has the footprint. But if you see, it has the schematic symbol printed on it on the silkscreen layer. So this is really nice when you're placing it. You know which is the cathode and which is the anode. So we're just going to head and we're going to click place. And I did select an 0805 LED, and we're going to start placing components, but I'm going to click tab. And so I don't need this comment in there. I'm just going to make that unclick the visible, and so it just disappears. And I can also select other different parameters that if I want to have it on there. Like if I want to say that it's yellow, maybe I think in this case I'm going to select that it's the parameter case package, the size is what I want to have printed. At least it's just on the schematic. And to rotate the component, you just press the space bar, and I'm going to place this roughly here. So that's going to be my output indicator. Since this is a boost converter, I'm going to have some voltage in and some voltage out. So I want a terminal block, 2 positions. So I just need positive and negative, and 5mm, and that's going to be the spacing. Now it brings up a whole bunch of stuff. So Octopart, the library that I'm searching in, is going to be your main repository of all the components. And so this is where you kind of scroll through and look for it. So I want to use this one, so I'm going to click that. And if you want to, you can actually click the yellow descriptor, and it will bring up the more details about it. It'll give you suppliers. You can get the data sheet. So it's a really nice feature. And we're just going to go ahead and click place. And so I need an input. And so I'm going to rotate it. And then I need an output. So I want that on the other side. Now you can see that the numbers are on different sides. I want actually like pin 1 to be both on the bottom. And in order to do that, I'm going to click tab. I'm going to scroll down here and click mirrored. Now, if I hit rotate, it's mirrored. So both pin 1s are facing down. And I also meant to make that not visible, just because it just clutters up the schematic. And so we're going to go here and make that also not visible. All right, so what I was saying is Octopart library is the main repository. These are all the components that you need that are available. You can actually make your own component. So for example, if I scroll all the way down, I actually think there's going to be a whole lot where they already have. Yeah. Well, eventually I'll find a component that, maybe it's missing the schematic symbol and the footprint. That would mean that this component it doesn't exist as an available component, but you can actually make that. But I'll have another video on that. So the library is user maintained. So if you make a component and you make it wrong, somebody else uses that, they'll be using a wrong component. If you make it so that there's an error in it, it might cause problems with Circuitmaker. So now we want to find a switch. Of course, we need to be able to turn this off. So I want EG1257. This is a switch that I've used before. One of the things that you'll maybe want to do is, as you come across these components, you can add it to your favorites. So all I did was hovered over it and then right-clicked. And this is also you can place. You can build a new version if it turns out that it is in fact incorrect, or you can just add it to the library. You can click this to add to favorites. And that's going to tell me I already have it. So we'll just click it. So obviously, if you didn't have it in your favorites library, then it would add it. So we can go and click to our favorites, and with that still typed in the field, we can click search, and I've already got that in my favorites library. But we're going to stick for right now with Octopart library. Now I want this boost converter switch, so I want the MCP 162442B dash adjustable. And one of the things you want to watch out for is that if you selected this one, there's no little isometric cube, there's no schematic symbol, and there's no footprint, and you won't be able to place it. But you can actually go in here and build this, but that will be for another video. So we're going to click this one. It's got a little isometric cube, and it's got the schematic symbol, and it's got the footprint with what looks like to be a 3D model. So we're going to click place, and we can click tab, see what the 3D model looks like. That's just a generic extruded model. That's not exciting, but that'll work for us for now. And I'm going to keep that, and I'm going to click OK, and I'm going to place that roughly there. Now, of course, oh, I didn't place the switch, did I? Jeez, I tell you. So we'll type that again, EG1257. G1257. And we're going to place that. And now I'm going to rotate with pressing the space bar. And I'm going to put that right about there. Hit escape. And I want a couple things. I want an inductor. I want my switching inductor, so I'm going to put in a 4.7 UH micro Henry / 2.3 amps. And I believe I want this worth. And again, we always want to check. It's got the schematic symbol, and it's got a footprint, and it looks like it has a 3D model as well. So we're going to place this one. I'm going to rotate this. Tab, space bar. If I hit the tab button, I don't need all these numbers. That doesn't tell me anything. It doesn't have any parameters, but I can add it. So I want to call this value, and I'm going to write, what was it, 4.7 microhenry, and let's make that visible. And click OK. So now it tells me that it's L question mark, and this is so that's a designator. I'll show you how to actually change this all simultaneously in another video. But for now, we can just go here and click L1 because we only have one. And so now we've got L1 and 4.7 microhenries, and this is D1. I'll change that to D1. And I definitely want to change these to VIN. And guess what? This one's going to be V out. Good call. One of the things about schematics is that they tend to go from left to right, the signal flow, and also the voltage. The positive voltage is usually on top and ground is on the bottom. It just helps things to be much more readable if you stick to that convention. And so we need some capacitors. And again, I'm building these in surface mount. You can probably build this same circuit using through-hole components. Now I'm just going to take this first one. This doesn't necessarily have to be the exact same capacitor I put on there, but I just need the basic footprint. And I'm going to I need one of my, I'm also going to hit tab. So one of the things that's nice is that Circuitmaker will automatically number them, but you have to do that before you place. So here I'm going to change the designator to C1. I got rid of the question mark, and I'm going to put one on the input side, and then it changes automatic increments to C2. I'm going to put that on the output side, and I'm going to give myself a little bit more space. Oops, haha, just kidding. And I also need, I'm also going to stick to 0805 size. So 0805 refers to, then that's going to be standard measurement. That's going to be 80 by 50 mils. That is the dimensions of the component. 1206, for example, would be 120 mils by 60 mils. So I want two resistors. I want a 680K. And I'm going to go with the Vichy. I'm going to place that. And again, here we've got this really long comment. I don't really need all of that. That's not helpful. But I would like to have the value. And again, this is, this having all the zeros makes no sense. So I'm just going to delete that and put K and select that and change this to R1 and click OK. Spacebar to rotate. So this resistor and the next resistor, they form the resistor network that sets the value for the output voltage. So you can change this. One of the things that's nice is that if you have the bare circuit board, then you can put whatever value you want on it as long as it's the same size and adjust the voltage output. And so I'm going to just click this. Yeah, let's stick with Vichy. Why not? And place. And again, it's got that long comment, so press tab, make that not visible. I'm going to call this R2. And I want, again, I don't know why they have all the zeros, even down to a tenth of a decimal. So I'm going to put, K, select that as visible, and tab to rotate. And and left mouse button, and then escape to remove it. Now I need a current limiting resistor. For that, I'm going to use a since it's 5 volts, I'm going to do 3. Actually, I should just do 1K. The LEDs I use, they actually have much lower current, so I need a higher resistor. And let's just shake things up, and we'll just use a different one. And click place again, tab R3 1K. And I'm going to make that keep that visible. It's interesting. And click OK. 3D model again is not really anything to get too excited about. And press that, escape. And I'm going to move that up a little bit. All right, so I've got all of my components placed, and so now it's just about connecting things. For those who like shortcuts, you can go up to just getting view, and you can click shortcuts, and you can scan through all the shortcuts for like placing components, for example. So we're going to use W, and we're going to use the Z and V a bunch. All right, so the next step is to actually just start connecting them all. So we're going to press. So you can bring up a wire one of a couple of ways. You can press the wire button up here. That brings up this little crosshatch, or you can press W, which is a shortcut for wires. And whenever you go over to a clickable part where it will connect, you can see how the inner X changes red and gets slightly larger. It's not as visible, but you can see it. So we're going to click that left mouse button once, and it will make 190-degree angle for you. And if you want the angle to go up and then over, you can press the space bar. And so we're just going to start connecting this up. And if you so we'll connect that to 2, and once I've connected it should release. And connect 3. That's going to go to the inductor, and from this capacitor up to there. And this one goes to the SW, so that's going to be the switching. VN, also that gets to the other side, as well as enable. That needs to be tied to high. And another shortcut that's really helpful is the ground. So we're going to press Z for ground. We're going to put one here. We're going to put one there, one there, one there, and one there. Now this is, think of this as like a variable. So this is going like in programming. So this is what's going to be a global label. And so if this ground is going to be the same ground wherever I put it, even if I have a multi-sheet schematic, which will be covered in another video, this ground will be the same thing that's on another sheet. There's also some other power ports, for example. These are all global variables. So if I put a 12 volt on this sheet and 12 volt on another sheet, it's all going to be the same variable. So these are more like how things are connected logically. Whereas what we're doing with the wires is we're connecting it directly. So you can also move the wires as you want, because it's nice when things are lined up much better. So for example, those grounds are, if we have these all at the same level, if you really want to get that in retentive, you sure can. So we're going to connect, obviously, our that needs to be connected to ground, that needs to be connected to ground. Both these are connected to ground. And I could put another one there, but you know what? I'm going to press spacebar to get the angle change. And we're just going to connect it to that. Now my V out is going to go from here. I'm going to first connect this up to pin 2. And then R1 connects that connects that. And that goes back to ground. So the way this works is that this voltage divider, or rather this resistor network, is what sets the output voltage. And so we're going to connect that. All right, so that is, and you can make this nicer. You can actually have all this one line. Actually, that might look a little better. But either way, a lot of it might just be style. So you could just have one of these connectors and just a single trace to cover it all. So again, this is the schematic symbol is just the logical connection. It's just the electrical flow. So this is not how the physical pin out is. Pin 1 would be up here and go down to pin 4, hop over to the other side, go to 5 and up to 8. Whereas a schematic is just a logical representation of the functionality. So you can see even the device it goes from left to right. So the voltage input is on this side and the voltage output is on the right side. Now that is the basics of a schematic. So this is the very basics of the boost converter. You can do all kinds of things like add comments, whatnot. But one of the things you want to make sure that you do as you're going is to I'll go up here to click File. And you just click Save All. It'll save the project and everything else. And then as we're ready to go on to the next part is to actually make these PCB layout, we're going to click Commit. And so this is basically saving it all up to the cloud. So if you click Save, it's not quite complete. You always want to make sure that you commit the file so everything is saved in the cloud. All right, and that's it for this particular video. And in the next video, we'll cover the PCB layout.